Hey, welcome back to the shop. Thanks for joining me again. Today's December 21st, aka the winter solstice, aka the shortest day of the year. And in the spirit of the times, we'll do a very short and sweet science experiment. So today we're going to talk about the electromagnetic force. So that means electricity and magnetism can be freely exchanged. They can be treated as the same. So to demonstrate that, I have a neodymium magnet, aka a rare earth magnet, or for the layman in the crowd, a wicked strong magnet, dude. And I also have a piece of copper. Now, as you know, copper and magnets, they don't really stick together too well, right? But if you have a piece of steel like this tool here, it sticks to it just fine, no problems. However, we do know that copper conducts electricity. So, interesting fact, when electricity flows through a conductor, that conductor is surrounded by a magnetic flux. Well, a magnet is also surrounded by a magnetic flux. So what do you think will happen when we drop this magnet through the pipe? Well, the magnetic flux from this will generate an electric current in this copper. That electric current, known as an eddy current, will also have an electromagnetic field around it, and that field will interact with this magnet. So let's see. It just barely falls through really slowly. You can hear it rattling around. I also have a larger pipe. Now obviously there's less coupling, right? By the time the magnetic flux reaches the edges of this copper, it'll be weaker, but it still falls slowly, but it falls a lot faster. But still slow enough where I can catch it at the bottom. Pretty sweet, huh? All right, guys, I'm going to take you in for a closer look. This is a top-down view. Here's the magnet. Here we go. It's beautiful, isn't it? All right, we're going to do it one more time. So I know you want to see this. Here we go. Awesome.